Okay, guys. Now on page 27, we have another example. Uh, to solve this question, I'm gonna give you some indications. Then I leave it to you as an exercise. Okay. Uh, the first indication or the first point that I would like to mention about this. Look at here. We want to calculate the area of this bounded region, right? Which is like roughly saying bounded between these two curves, the parabola and the line. Of course, to describe the region R, we need to find the intersection points of these two curves. Look at here, this curve and this line, this parabola and this line. We need to find the intersection point or points of these two curves. It means this and this. So here the intersection points are given. But let me ask you something. If the intersection points are not given, it means if we don't know what are these 2 points, how do we find them? Okay, this is the first point. We find these 2 points like this because these 2 points are the intersections point of this parabola and this line. So you have to solve this. You have to solve this system. A system of y equals x squared, and the other one is y equals x plus 2. Y equals x plus 2. So it means simply you put x squared equals x plus 2 and solve this equation. It means you have x squared minus x minus 2 equals 0. If you solve this equation, you get this answer. Actually, this is easy, right? Like we have x plus 1 times x minus 2, correct or not? So the product of these two is minus 2 and the sum is minus 1. So from here you get x equals minus 1 and x equals 2. So you can see here, let me show you. So here x equals 1, x equals 2. It means if the intersection points of these two curves are not given, so you have to solve this system. You put x squared equals x plus 2 to find the intersection points of these two curves. So when x is minus 1, y is 1. When x is 2, y is 4. Okay, so here to describe R, you can say x is from, look at here, minus 1 to 2. Okay, x is from minus 1 to 2. So x is from minus 1 to 2. And y is from parabola. It means x squared to line. It means x plus 2. So now we can describe the region R. So x is from minus 1 to 2, okay, here. And y is from x squared to x plus 2, here. So y is from x squared to x plus 2. So this is how we find the intersection points, and this is the description of region R. Now we can set up integral to find the area. Let me now erase these two to continue. Okay, so this is the description of region R. So this integral equals from -1 to 2 for x, and from x squared to x plus 2 for y. And dA will be dy dx. So the first integral with respect to y, second with respect to x. Okay, so I'm gonna leave it to you. This is easy. Please go ahead and find the answer. Okay, this is easy. So first you integrate with respect to y, then with respect to x. And remember, the answer must be positive because we are calculating the area. And one more point that I want to mention about this example, look at here on page 28. It's the same example. You can see the region R is divided into two regions, R1 and R2. We don't have to do this, okay? I already show you how to solve it. But if you divide the region R into R1 and R2, then you have to switch the order of integration to dx dy. Okay, and then you have to find the area of R1 and R2 separately. Then the sum of the area of R1 and R2 becomes R. But that is more complicated. Okay, so this will be the easiest solution. Please go ahead and find the answer.